Okay, so today we're working on both 12.4 and 12.5, and we're going to be finding volume of all of the solids that we've talked about so far. So I know how we separated 12.2 and 12.3 into 2 different days, but for like having cylinders and prisms on 12.2 only, and then pyramids and cones on 12.3. But today we're going to get to work with all of these things. So it is important to remember what shape your base is in order to find the appropriate area. Make sure you're using your area formulas from chapter 11 for your circles or your regular polygons or rectangles or whatever other shapes you have. So for a prism or a cylinder, to find the volume, you're simply going to take the area of the base times the height. Remember, the height is the distance between the bases. Okay? Now, for a pyramid and a cone, it looks almost exactly the same, except you're going to take 1/3 the area of the base times the height. And that height is the distance between the base and the vertex of the pyramid or the cone. Both of these distances need to be perpendicular to those bases. So, if I look at number 1, we're asked to find the volume of the prism, round to the nearest tenth. So if I look at this prism, I'm looking for the rectangles so I know which one's the lateral faces and then which sides are the base. And so that means that these triangles are my base. So this would be a triangular prism. So for our base, we need to find the area of a triangle. So 1/2 the base times the height. Since this is a right triangle, the base and the height are adjacent to the right angle. So we'll need to take 1/2 of 8 times 5. 8 times 5 is 40. Half of 40 is 20. So the area of our base is 20. The height of the prism is the distance between the two bases. So the height of our prism is 3. So volume equals the area of the base times the height, or 20 times 3. So our volume is going to be 60 centimeters cubed, because volume is a cubic measure. And that's it. For number 2, it says find the volume of the prism. So let's find those bases. And so if I look here, this isn't a rectangle, so that's one of my bases, and neither is this, so that's the other one. So this is a trapezoidal prism. So to find the volume, we'll need the area of the base, so 1/2 base 1 plus base 2 times the height of that trapezoid. So the bases are the two parallel sides, so 4.4 and 5.6. So 4.4 plus 5.6 times the height, which is the height or the distance between the two bases, which is 2.5. So then if I take my handy dandy calculator and go 1/2 parentheses 4.4 plus 5.6, close parentheses, times the height, 2.5, gives me a base area of 12.5 meters squared. So then if I look at my figure, I need the distance between the two bases, which will be the height of my prism, which will be 4.2. So just be sure to be careful. This is the height of the trapezoid. This is the height of our prism. So volume equals area of the base times the height. So 12.5 times 4.2, which gives me a total volume of 52.5 meters cubed. So for number 3, it says find the volume of the cylinder. Round to the nearest tenth if necessary. So if I look at this one, I'm like, okay, so it's a cylinder. I notice that it's an oblique cylinder, which means that it's kind of slanty. You can see how our our edges right here are not perpendicular to the base. But we can still find the volume. So the area of the base would be pi r squared. So pi, our radius is 7. So if I was writing this in terms of pi, I would have 49 pi. But it does ask us to round to the 10th, so I'm going to use that. So 49 times pi is 153.9, and it's 938. So I look at the 3 is not 5 or greater, so it doesn't change it. So that's feet squared. So then for our volume, area of the base times the height. So 153.9 times the height, which is that perpendicular distance from one base to the other, so 22. So 153.9 times 22 gives me a total volume of 3,385.8 feet cubed.